Good food is hard to resist, especially ones rich in oil and prepared with flourish. But just as excess of everything is harmful, so is gorging on fatty foods. Very soon a discomfort sets in, and then it is up to chemistry to rescue you. And that too with just one glass of antacid. Wondering how this quick fix solution came about? Keep thinking. Hello and welcome to the show. From the ocean water to the human body, there is at work a principle that ensures balance by give and take. What is that and how does it accomplish such a tough task? We will find that out and more in today's episode. Together, we will study ionic equilibrium, classify acids and bases, distinguish between strong and weak electrolytes, and also learn about the degree of ionization. Finally, there will be exam decoded with the promise to give you all the help to maximize your scores. Let us begin today's session by classifying substances into electrolytes and non-electrolytes. According to Michael Faraday, substances which conduct electricity in aqueous solution are called electrolytes, and those which do not conduct electricity in aqueous solutions are non-electrolytes. Now, electrolytes are further classified as strong and weak electrolytes. If the electrolyte almost completely ionizes on dissolution in water, it is a strong electrolyte. Whereas, if the electrolyte ionizes only partially, it is called a weak electrolyte. Let me explain this with an example. An aqueous solution of HCl will ionize almost completely into hydronium and chloride ions. Hence, it is a strong electrolyte. In case of acetic acid, only partial ionization takes place. Only a part of it ionizes and the rest remains unionized as a molecule. This is because an equilibrium is established between the ions and unionized molecules. This type of equilibrium involving ions and unionized molecules in aqueous solution is called an ionic equilibrium. Remember my assertion about critical balance in our blood and even the ocean? That was because these are also solutions of electrolytes, and an electrolyte balance or an ionic equilibrium is equally crucial in their regard. For instance, elevated potassium levels may result in cardiac arrhythmias, and decreased extracellular potassium produces paralysis in human body. Ocean water too is a solution of biochemically important ions like methane, oxygen and carbon dioxide, and a shift in their ionic equilibrium can play havoc with ocean life. Now that you are thorough with the concept of what an electrolyte is, let's study its classification in greater detail. Electrolytes are classified as acids, bases and salts. Swedish scientist Svante August Arrhenius in the year 1884 put forward a theory whose central premise was that when an electrolyte is dissolved in water, it dissociates into positively and negatively charged ions. Based on this theory, Arrhenius went on to define acids and bases. An acid is a substance that dissociates in water to give hydrogen ions, while bases are substances that produce hydroxyl ions when dissolved in water. At this point, I would like you to see how to represent a proton with the help of a figure. Do pay attention, as this will help you in solving acid-base reactions that are asked in the exams from this topic. A proton can be represented as H+. It is very reactive and so cannot exist freely in aqueous solutions. It bonds with the oxygen atom of the solvent water molecule to give the trigonal pyramidal hydronium ion H3O+. Now, keep this information stored away till we need it again. Apart from Svante August Arrhenius, a scientist duo of Jonas Nicholas Bronsted of Denmark and Thomas Martin Lowry of England are responsible for their historical contribution towards understanding this subject better. In 1923, Bronsted and Lowry, working independently, came up with an identical explanation of the behavior of acids and bases. This explanation came to be known as Bronsted-Lowry theory and stated that an acid is a substance that is capable of donating a hydrogen ion and a base is a substance capable of accepting a hydrogen ion. In short, acids are proton donors and bases are proton acceptors. Such reactions involving removal and addition of protons, named after their significant discovery by Bronsted and Lowry, are referred to as Bronsted-Lowry acid-base reactions. It is time now for you to recall the nugget of information on protons that I had asked you to hold on to. To understand the addition and removal of protons as discussed, let us consider a general reaction between Ha and B. In this reaction, Ha acts as a proton donor and B acts as a proton acceptor. Thus, Ha will act as an acid and B will act as a base. In their interaction with each other, Ha will donate a proton and get converted to A-. Here, the acid-base pair of Ha and A- differ by one proton. Hence, they are called conjugate acid-base pair. Similarly, base B and BH+ also form a conjugate acid-base pair, where BH+ is the conjugated acid of base B. Acid-base reactions can easily be understood and expressed in terms of conjugate acid-base pairs, which differ by one proton. Remember, the conjugate base of an acid is one proton less than the acid, and the conjugate acid of a base is one proton more than the base. As far as the equilibrium is concerned, it moves in the direction of formation of the weaker acid and weaker base, because the stronger acid donates a proton to the stronger base, which means that if Ha is a stronger acid than BH+, then Ha will donate protons and not BH+. Thus, the solution will mainly contain BH+ and A- ions. I think we have covered sufficient ground till now. Why am I saying that? That's right. I have a question to test you on all that we have just discussed. Ammonia has the formula NH3, but is still considered a base. Do you know why? Think about the answer while I take a short break. When I come back, I will give you the answer to this question and much more. So stay tuned. Welcome back. So could you find the answer to the question I had asked you before the break? The question was, ammonia has the formula NH3 but is still considered a base. Do you know why? Well, you can thank the scientist duo Bronsted and Lowry, who had an explanation for this as well. Ammonia is a base because it accepts a proton and forms a conjugate acid NH4+. Do remember to keep practicing such conceptual questions because they have a very high probability of being asked in your exams for 1 mark. For a large part, the scientific world studied acids and bases on the basis of the Arrhenius concept and the Bronsted-Lowry concept. However, a Hungarian biochemist had once said that a discovery consists of seeing what everybody has seen and thinking what nobody has thought. And Gilbert Lewis, a scientist from the US, proved that by proposing another way of looking at and defining acids and bases. Lewis defined an acid, a species that accepts an electron pair, and a base as a species that donates an electron pair. Lewis also gave the world the Lewis structures, also called Lewis dot diagrams. These diagrams show the bonding between the atoms of a molecule and the lone pairs of electrons that may exist in the molecule. Lewis' depiction of an acid-base interaction is that if A is a Lewis acid, it accepts a pair of electrons from Lewis base B. The concept was revolutionary because it eliminated the necessity of the presence of hydrogen in an acid and hence included many more substances as acids and bases. For example, using the Lewis structure, one can easily understand the reaction between boron trichloride and ammonia. In this reaction, BCl3 is electron deficient and hence acts as a Lewis acid, and NH3, which is electron rich, acts as a Lewis base. For the reaction to proceed, BCl3 accepts a lone pair of electrons from NH3. At this point, let me take you back to the beginning of this show, where an antacid liquid cured indigestion in a flash. I am sure the chemistry behind it is pretty evident to you by now. It was an acid-base reaction at work. Our stomach produces hydrochloric acid to help in the digestion of food without harming the stomach. During indigestion, the stomach produces too much of this acid, which causes pain and irritation. Antacid, which is actually a base, reacts with the acid and settles the stomach. Now, as you know, acidity and basicity of substances can be relatively determined. An acid can be stronger or weaker than any other acid, and likewise for a base. But how does one measure the strengths of acid and bases? Chemistry has the answer. The key lies in the expression for equilibrium constant. For a weak acid, Ha, we can write the equilibrium constant as K is equal to the product of the concentration of H3O plus ions and A minus divided by the product of concentration of HA and water. Since we are taking an aqueous solution into account, water is present in large quantities and its concentration remains practically constant. Multiplying K with the concentration of water gives another constant Ka, which is known as dissociation constant or ionization constant of the acid. Thus, we can say that at a given temperature T, Ka is the measure of the strength of acid Ha. Larger the value of Ka, the stronger is the acid. Now, for the ionization of a weak base BOH, we can write the equilibrium constant as K is equal to the product of concentration of B plus ions and OH minus ions divided by the product of concentration of BOH and water. Here too, water is present in large quantities and its concentration remains practically constant. Multiplying K with the concentration of water gives another constant Kb, which is known as dissociation constant or ionization constant of the base BOH. So, at a given temperature T, Kb becomes the measure of the strength of the base BOH, and larger the value of Kb, the stronger is the base. It's time now to answer a rather interesting question from a young friend.
In quite a few numericals for calculation of ionization constant, the term degree of ionization is used. How are they both related?
Knowing the answer to this question is very important because it will help you score well in your exams. To begin with, you must know that the degree of ionization gives the extent of ionization and is represented by alpha. Let us take an example of a weak acid Ha, which dissociates into its constituent ions. Suppose the initial concentration of HA is C moles per liter and degree of ionization is alpha. Now, the equilibrium concentration of HA will be C into 1 minus alpha, and that of H3O plus and A minus will be C alpha. Substituting the values in the expression for Ka, we will get the value of degree of dissociation as square root of Ka divided by C. A similar relation can be deduced in the case of a weak base, say BOH. Let the initial concentration of BOH be C moles per liter and degree of ionization alpha. Now, the equilibrium concentration of BOH will be C into 1 minus alpha, and that of B plus and OH minus will be C alpha. Substituting the values in the expression for Kb, you will get the value of degree of dissociation as square root of Kb divided by C. It's time now to find out how much you have absorbed from all that we have learned in the session so far. And what better way to test you than with a set of questions likely to be asked in your exams. You have guessed it right. It's time for exam decoded, but right after a short break. So stay tuned. Welcome back to our episode on ionic equilibrium. Before we move on to exam decoded, let's first revise all that we have studied today. In today's episode, we learned that substances can be classified into two types, electrolytes and non-electrolytes, depending upon their ability to conduct electricity in aqueous solution. Electrolytes are classified as acids, bases, and salts. According to Arrhenius theory, acids give hydrogen ions while bases produce hydroxyl ions in their aqueous solutions. Bronsted theory defined an acid as a proton donor and a base as a proton acceptor. Lewis gave the definition of an acid as an electron pair acceptor and a base as an electron pair donor. The degree of ionization alpha is defined as the extent of ionization. After that summary, nothing should stop you from taking exam questions head on. Welcome to Exam Decoded. As always, we shall begin with the rapid fire round. Though you are no stranger to the rules, here is a quick overview. You will get 5 questions, each to be answered in 5 seconds. Award yourself 1 mark for each correct answer. And in the end, we will calculate your score to know how close you are to attaining equilibrium between knowing and scoring. Here is the first question. The conjugate base of sulfuric acid is A, HSO4-, B, H-, C, NO3-, D, Cl-. The answer is A, HSO4-. That was easy. Moving on. Which of the following is a Lewis acid? A, OH-, B, NH3, C, H2O, D, BCl3. The answer is D, BCl3. Here comes the next question. Fluoride ion is a Lewis acid. Is it true or false? Well, this is false. Fluoride ion can act as a Lewis base as it can donate any one of its lone pairs. Here is next question. Larger the value of Ka, the stronger is the acid. True or false? The answer is true. Here comes the last question. Electron pair acceptor is A. Lewis base, B. Lewis acid, C. Arrhenius acid, D. Arrhenius base. The right answer is option B. Lewis acid. It's time now to evaluate your scores. If you have got all correct, you are our topper high flyer. Excellent work. If you have scored between 3 and 4, you are an achiever, and with a little more effort, you will soon be right on the top. If you have scored less than 3, then there is surely scope for improvement, and you can easily find expert guidance, practice questions, and exam tips on our website www.topperlearning.com. The topic Ionic equilibrium belongs to the unit equilibrium and carries a weightage of 6 marks, making it a critical unit in terms of scoring. From it, your numerical and knowledge abilities will be tested with short answer type questions for 2 or 3 marks. Let us now solve a sample question and look at the ideal way to answer it. The question is, calculate the ionization constant for ammonium hydroxide if it is 40% ionized in its 0.01 molar solution. This question carries 3 marks. And here is how you should answer it. Ammonium hydroxide ionizes into ammonium and hydroxide ion as shown in the equation. As given in the question, the initial concentration C of ammonium hydroxide is 0.01 molar. Now, if the electrolyte is 40% ionized, degree of ionization alpha is 0.4. Getting to the value of alpha will get you 1 mark. We know that degree of ionization of a base is given by the formula alpha is equal to square root of Kb divided by C. Writing this formula correctly will fetch you 1 more mark. Substituting the values of alpha as 0.4 and C as 0.01 in the formula, we will get the value of ionization constant for ammonium hydroxide Kb as 16 into 10 raised to power minus 4. Calculating this final value correctly will fetch you another 1 mark, taking your tally to the desired 3 marks. Now it's time to hear an exam expert's view of how to prepare ionic equilibrium for your exams. Don't forget to note all the tips and tricks.
Ionic equilibrium. Students get frightened by the name itself. It's not so. The chapter is very simple. The only thing they have to remember is the importance of Arrhenius theory and the Bronsted theory. Both the theories state the same thing, what is an acid, what is a base, but they state in a different manner. Next important thing is the concept of conjugate acid and base. They should remember, for a strong acid, the conjugate base is weak. For a strong base, the conjugate acid is weak. Let us say HCl is a strong acid. When it loses its H positive, Cl negative ion is formed, which is a weak base. Similarly, NaOH is a strong base. When it loses its OH negative, Na positive is left, which is a weak acid. If students remember these things, they can very easily crack the questions related to this chapter and get very good marks in their exams.
I am sure by now all your exam anxiety has been neutralized and you have reached that state of equilibrium where you will successfully balance both work and play. Before I leave, let me tell you something interesting. Sodium bicarbonate, which treats heartburns and acidity, is also used to bring out the lost shine in silver ornaments. Intriguing, isn't it? If you are interested in finding out more such scientific facts, do log on to www.topperlearning.com. Till next time, keep thinking and keep discovering.